Hey guys, welcome to my channel. So this is a very important tutorial for you guys because it is a decision tree and there is a lot of applications for decision tree in artificial intelligence, machine learning and those kind of stuffs. And also it is really important to learn decision tree because it has a lot of concept and a lot of important things that you should know about it. One of them, to understand decision tree, you need to know what is entropy is. So in the beginning you should learn a formula for any set given as the entropy S is equals to summation of 1 I is equals to 1 up to n based on your dataset. If your dataset is 100, the I goes up to 100. If your dataset is given like 10 dataset you have, it will go I is equals to 1 to 10. And the main formula is minus pi log 2 pi. Pi is the probability of that event happening, yes or no. This is the probability of that event happening, okay, and this p is the probability of that not happening, the probability of not happening, and this pi is the probability of happening of that. So this is based on yes and this is based on no, the probability of yes and the probability of no. So 2 based on, and obviously it is log 2 based. So our final formula is summation of I is equals to 1 up to n minus pi log 2 pi. So this is the formula that you will find the entropy. Now why should you learn to find entropy in decision tree algorithm? Pi is equals to probability of target variable. It can be yes is for first one, this one, and no for this one. Probability of happening yes plus probability of happening no out of total outcome. So this is means the probability. So let's understand by a simple data set. Suppose we have a variable table head which is book type. We have fiction, drama, fiction. Okay, we have two types, fiction and drama. And our book writer, if it is fiction, our book writer is John Doe, and it says label data which one to buy. Do you want to buy that? No. If your decision is, if you take a decision that you are buying a fiction type book and its writer is John Doe, then you are not going to buy it. And if your book type is drama and your book writer is Mike Jonas, then you are buying it. And the book type is another which is fiction. If your book writer is Mike Jonas, then you are going to buy it. It says that if you buy book which is drama book or fiction book, both type, if the writer is Mike Jonas, you're going to buy this book. But if the book is fiction and the book writer is John Doe, then you are not going to buy this book. So here in the last example, here we have drama again. So John Doe writes fiction book and drama book as well. But when John Doe writes some book like John Doe writes fiction book or John Doe writes drama book, then you are not going to buy it. No. When the book writer is Mike Jonas, the outcome is yes. The probability of buying books is 2 by 4 because there are 2 yes out of 4. And the probability of buying not books, which is also 2 by 4 because there are 2 probability that you are not buying the books out of 4. Okay. Suppose we take book type which is fiction, and fiction we have John Doe and Mike, both have write the fiction book. So when we take the fiction type, when we classify is as fiction, if we classify this with book type, then you are not going to buy the book and for John Doe, and you are going to buy the book for Mike Jonas. So why this variation? Your probability is always half because there are 2 possible outcome, yes or no, and the possibility of buying no is 1 by 2 and the possibility of buying yes is 1 by 2, 0.5, which is really bad. So you need to remove this kind of thing. So these bad kind of things, the probability is 0.5, which is not any decision. Okay, it is a tie, it is like a coin toss, so it is not useful to us. So that's why you need to decrease your entropy and find it in a proper manner so that you can find your proper decision based on decision tree. That's why you need to reduce the entropy of your data sets, of your feature data, and make it proper way, an organized way to make it less entropy and less problematic. So this is the main thing that we need to know what is entropy is. So let's see a diagram, entropy versus probability. When your probability is 0, your entropy is 0. So this is what we want, what is suitable for this algorithm. When the probability is 1, it means that you are going to buy this book for sure. There is no in that. So then your probability is 1. In that case also your entropy is 0. But the problem arises when your probability is 0.5, which is same as this case. You are going to buy this book which is 0.5 probability. So this is the bad case. So in this case your entropy is 1, highest entropy. So you need to reduce it. This highest entropy is not good for this algorithm. So you need to reduce that in some way, okay, to make it perfect for your algorithm to set your data sets. So this is the main thing that you need to learn in decision tree. Now we have another solution, that in our decision tree, which feature should be on the top of our decision tree. Now let me see you the decision tree. So our final decision tree would be looking like this. The temperature, if your temperature is warm, then you are not wearing coat. So we are taking decision based on this parameter, that do you have to wear coat in this situation. The situation is temperature can be cold or warm. In case of warm, you are not going to wear coat. When the temperature is cold, there is a huge possibility that you are going to wear the coat. But you need to see another condition, your outlook. Outlook can be cloudy, it can be sunny. But when it is cloudy, you are going to wear the coat for sure. But when it is sunny, still you need to check based on routine. Is it indoor or outdoor? In indoor you have AC. So in indoor condition you don't need to wear the coat because there would be air cooler in case of sunny weather. But when the weather is sunny and you are outdoor, okay, then you might have to wear it. Okay, so in this way we are structure our thing. So this temperature, outlook, routine, those are the things are our feature variable, and based on it we will result that if you want to wear the coat or not. You take decision. So which one should be in the root, temperature or outlook or routine, we will calculate it using some formula. So let's say this. So there is a very important thing we need to know, which is gain. Gain as the entropy of S. You need to find the entropy of your total data set minus the summation of V elements of values of A. A is the element that you're given, like temperature, outlook, those type of things. You need to find those values, probability, and their own entropy. Okay, so you will understand it more perfectly when we give you some example. Without it you won't understand it easily. So we have a day. You can say it as index 1, 2, 0, 1, 2, 3, 4, 5, 6, this type of indexes. And our main features, which is our main variables, is outlook. It has sunny, cloudy, different kind of weather situation. Our temperature is another variable which can be cold or warm. And our routine can be indoor, outdoor, this type of routine. And based on these three parameters, these are the feature parameter of our dataset. So based on that, we're going to make a decision that we're going to wear coat or play outside, anything like that, this type of things. So let's see how many dataset we have. We have total 1 up to 7, total 7 dataset. Based on up to 7, we have only 3 yes and 4 no. The total is 4 plus 3, which is 7. Total is 7. Out of that, 4 is no. Probability of getting 4 is 4 by 7. And probability of yes is 3 by 7, because 7 is the total outcome, and out of that 3 is our yes. So 3 by 7 is our main probability of getting yes in total set. So let's see our total data is 7 and our total feature data is 3: outlook, temperature, routine, which is same as outlook, temperature and routine. This is our feature. Our predictor that we need to find, which is take decision on that we should wear coat or not based on this weather condition. And our total yes is 3, total no is 4, total is 7. So let's find the entropy first of the total data set, which is minus 3 by 7 log 2 3 by 7. This is actually the yes part of our probability, minus pi log 2 of pi. So 3 by 7, which is there is total 3 yes out of 7, so that's why it is 3 by 7. Log 2 is our formula, log 2, and 3 by 7 is same as total 3 yes divided by total outcome is 7. Same as these two values will be always same in any data sets. and 4 by 7, this part is our no, probability of getting no, which is 4 by 7, because there are 4 no here and total values are 7. So 4 by 7 log to 4 by 7, our output is 0.985. This is our entropy for our entire data set. Now we need to find individually for outlook, temperature and routine, and see whichever output, whichever feature gives us the most gain. Whichever will give us the most gain, we will take it at the top of our root. So that is why we need to find the gain, so that we can set each of those features gain, and based on this gain, whichever should be our top of the list, our root of the tree. So this is the main thing that you need to understand, because in the previous example that we see, the decision tree that I have showed you, the temperature is on the top because its gain is the highest. Let's see if it is true or not. So let's find it for outlook. All of the things are same for each individual feature, so I'm showing you only the outlook part so that you can understand it more easily and do your homework after that. So first, in outlook we have two parameters, sunny and cloudy. So as you can see, in outlook we have sunny and cloudy, two type of thing. And how many yes and no are there in sunny? So there is 1 yes and 3 no. Let's find it. So in our database table we have outlook for sunny 1, 2, 3, 4. So total 4 sunny. Out of that, 1, 2, 3. 3 of them are our no. This one is no. This one is also no. This one is also no. So 3 no and only 1 yes. This part is the yes. So there are total 4 sunny, and out of them 3 of them are no. So there are 3 no, you can write it as 3 minus, and only 1 positive, which is yes, 1. So total 3 plus 1, which is 4, because there are total 4 sunny and 3 cloudy, and total 3 cloudy, and 4 plus 3, which is total 7, which is our total dataset items. And in cloudy we have 2 yes and 1 no. In cloudy 1, 2, 3 cloudy and 1 no, 1 yes, 2 yes. So in 3 total 1, 2, 3 cloudy, we have 2 yes and 1 no. So we need to find the entropy of outlook sunny. So the entropy of outlook sunny is minus 1 by 4 log to 1 by 4, which is the positive part, because there is only 1 yes, so this is 1, and there is total 1 plus 3, which is total outcome, which is 4. 1 by 4 log 2 of 1 by 4 plus 3 by 4 log 2 3 by 4. 3 is the negative part, probability of not happening. Out of total 3 is total no is 3, and our total yes and no, if we add all of those items, total 4. So total outcome is 4, out of them 3 is no, log 2 3 by. So this is the no part, this is the yes part, and our information gain is 0.81. Now we need to find it for outlook cloudy, because there is 2 part of outlook, one is sunny, one is for cloudy. Same way you would find it for cloudy. For cloudy it would be total item is 3, so, and out of them 2 is yes, so 2 by 3 log to 2 by 3, 1 is no, so out of 3, so 1 by 3 log 2 of 1 by 3, so 0.918, which is the information gain. Now our total gain is S. Okay, so the entropy of our total data set and our outlook. So entropy of our total data set is E of S, which is 0.985, which is coming from here, 0.985 minus 4 by 7. So 4 by 7 is in outlook. Okay, we have total 4 items, which is sunny. Total 4 is sunny. Divided by 7. 7 is the total data set. Total data set is this one, because we have total 7 items, so total 7, and total 7 is, out of them 4 of them is sunny. So times 0.811 is the entropy we get from sunny, which is 0.811, minus 3 by 7. 3 is the number of clouds. Number of clouds we have 2 plus 1, which is 3, total 3 clouds. So let's see, 1, 2, 3. Out of 7 we have 3 clouds. So out of 7 we have here 3 clouds. So 3 by 7 times the entropy of outlook for the cloud, okay, which is 0.918 and times 0.918. So total minus 4 cloud divided by 7 total item times its entropy, cloud's entropy, minus 3 by 7 times the cloud's entropy, which is 0.918. So this is the total thing that you learn. So just apply all those values and calculate it, you get 0.128. This is the gain, total gain for your outlook. Same way you will find it for temperature. There is total 4 items which is cold, and out of them 3 of them is yes, 1 of them is no, total 3 items of them warm, and there is 3 items which is no and only 0 items which is yes. And now this is solved. If your temperature is warm, there is always no, so the probability of no is 100% if the temperature is warm. So you are not wearing the coat if your temperature is warm. So we can say that when you there is warm, there is always negative answer. When the temperature is warm, you are not going to wear the coat. So let's see it in our data set. So when your temperature is warm, there is always no. When your temperature is warm, it is no. Temperature warm, no. So there is no possible yes case. This one is solved because there is no problem in that data set. The probability is always 1, so our entropy is 0. So that is what we want. But here our entropy is not 0 because there is mix between yes and no. So you need to calculate it more further. So temperature of cold, which is minus 3 by 4 log to 3 by 4, which is 3 by 4 because there is total 3 possible cases of yes out of 4. Okay, so 3 by 4 log to 3 by 4 and 1 negative cases, so 1 by 4 because there is total 4. 1 by 4 log to 1 by 4, which is 0.811. So temperature cold. For warm we can calculate it, but its output would be always 0 because there is the probability of no is 100%. Okay, so which is 0 by 3 log to of 0 by 3, which is because there is 0 cases here of 1, and also the no possibility of no is all of them, which is 3 by 3, 3 out of 3, log 2 of 3 out of 3. So this is very simple. You just need to know some probability and it is solved, which is 0. The same way you find the total minus 4 by 7 because there are total 4 of them the cold appeared, so 4 by out of 7 times its entropy. And for warm you have 3 by 7, 3 times you have the warm, so out of them you get out of 7, so times its entropy, which is 0. So you get the entropy 0.521, which is gain for your temperature. So for same way you find it for your routine. I'm not going to explain it about routine. You will find the same way as you do entropy for your indoor, entropy for your outdoor. You find it and just multiplicate it, minus multiplicate it and its probability, and multiplicate with its own individual entropy that you find before. So same way 0.128. So according to all the gain, we have outlook 0.128, temperature is 0.521, and routine is 0.128. So our highest value is temperature. The highest gain we get is from temperature. So temperature will be the root of our node. So let's build our partial tree. The partial tree would be temperature. If it is warm, then always no. So D2, D3, D4, we don't need to calculate these indexes. But when the temperature is cold, then you need to calculate further because there is a lot of entropy there, but there is no entropy. There is no entropy here, so we do not need to worry about it. When the temperature is warm, there is always no answer. But we have to consider the left side only, which is D1, D5, D6, D7, which is index 1, 5, 6 and 7. And out of them, 3 of them are positive and 1 of them is negative. So let's find this. D1, 5, 6 and 7. This is our new data set. You cannot work with all of the data set because you calculate them before. Now your new data set would be like this. Day 1 sunny, cold, indoor, no. D5 cloudy, cold, indoor, yes. This type of thing. You need to just work on this data set. And based on this data set, you need to find the new total entropy. So our new total entropy ES1, this is our new entropy of the total data set, which is based on these 4 items 1, 5, 6 and 7, which is coming from 1 5 6 7, this type of thing. 3 by 4 minus bracket 3 by 4 log to 3 by 4, which is the positive part, because our total data is 5, because our total data set is 4 1 2 3 4. Out of them, 3 of them is yes, so 3 of them, this one, this one, and this one, 3 of them is yes and 1 is no out of our total 4 data sets. So the probability is minus 3 by 4 yes, which is 3 of them is yes out of 4 data set, log 2 3 by 4, and only 1 is negative, 1 by 4 log 2 of 1 by 4, which is 0.811. So same way as previously, we need to do the same information gain. We need to find the same information gain for Outlook routine. So for I am going to show you just only one for the new data set. Remember, our new data set is only 4 items. So Outlook for sunny and cloudy. In Outlook we have 2 times sunny and 2 times cloudy. Okay, so 2 times sunny, 2 times cloudy, 2 times, total 4 times. You need to match it up because there are 4 total data. So total 2 times cloudy and 2 times sunny and 2 times cloudy. So out of sunny, let's find how many positive. 1 2 sunny, 1 no, and 1 yes. So here we have 1 yes, 1 no. So entropy for Outlook sunny would be minus 1 by 2 log 2 of 1 by 2 for positive one, plus for negative one we have only one item out of 2, 1 by 2 log 2 of 1 by 2, which is 1. And we need to same find it for cloudy, which is 2 of them are yes and 0 no. So when there is cloudy, suppose 0, this one and this one, 2 cloudy, and both of them are yes. So our entropy for cloudy, so our entropy for the cloudy is 0. There is no problem with it. When our Outlook is cloudy, you are going to when our Outlook is cloudy, you are going to wire code for sure. So its probability is 2 by 2 log 2 of 2 by 2, because there is 2 items and both of them are yes. So 2 by 2 log 2 of 2 by 2 plus 0 possibility of no, so 0 possibility of no, so 0 by 2 log 2 of 0 by 2, which is 0. So in this case you will find E of S1. The total entropy of a data set for this one is 0.811 minus 2 by 4. 2 of the items there in sunny, 2 items in for the sunny out of 4 data set, 2 by 4 times its entropy for sunny, and same minus 2 by 4 for this is the probability for this cloudy, 2 by 4, because 2 of them are cloudy and out of 4 items, so times its entropy for cloudy, which is 0. So total output is 0.311. for this is the final gain for the Outlook. Now same for routine, and you need to find it for this dataset D1, D5, D6, and D7 for this new dataset. In the same way, you will find all of those things, and then we can take any of the routine and Outlook, because you get gain from routine, which is 0.311, and when you get gain from Outlook, which is 0.311, both of the gain are same, so you can take any of them. Okay, so we just find it for routine and Outlook, because in previous data set here we already had put the root of our tree as temperature. Temperature is already defined. We have cold or warm. We just calculated this part, not this whole tree. So our temperature would not be calculated here. Only we need to calculate for Outlook and for the routine. So we find for temperature, if it is warm, it is no. When there is cold, we check our Outlook. And if it is cloudy, obviously you're going to wire the code. If it is sunny, okay, and then you need to check the routine. Okay, if it is outdoor, you are wiring the code. If it is indoor, you are not wiring the code. So this is the main decision we have. Okay, so this is based on our decision tree. So these are all the formula, the technique that you need to know and apply. Just get the gain of each individual item in your feature. Like Outlook, we can have 3 features, another, sunny, cloudy, or different kind of thing. Then we need to find those 3 individual entropy for each of those items and their probability. This is actually their probability of happening out of total, which is 2, out of happening, which is 1. So this is the probability, and this is the probability of not happening, no. So we need to find it for sunny, cloudy, of all of them, and just this formula, simple, just add this and you get the answer. The highest gain that you get would be on the top of our root of the tree, like this. Temperature has the highest gain, so we add it here. After that, we calculate outlook and routine. Whichever has the maximum gain, you add it in the second place, and whichever is the last, add it in the last place. If both of them has the same gain, you can add any of those, which is the perfect. So this is the thing that you learn in decision tree algorithm, which is one of the most interesting and one of my favorite algorithm to learn in machine learning algorithm, which is not that easy, but it is really interesting and fun to learn. And it's also very important to learn the whole concepts of gain, entropy, making the decision tree based on your features. So this is all the thing that I know about decision tree algorithm. I'll be making practical video on scikit-learn and Python. So till then, wait for it for my next video and keep watching my channels. Thank you guys. Wait for the next video.